Hello everyone. Seems that we are live. So good morning, good evening, good afternoon, depending on where you are. My name is Jakub and this is Tanzu.tv. This is our weekly show, by the way. Runs every Wednesday at noon Pacific time. So I strongly encourage you to mark your calendars because it's our weekly show. Besides that, we have shows on Tuesday. It's called Tanzu Tuesdays. We have shows on Thursday too about Kubernetes. So if you are interested, just check tanzu.tv and find something interested and mark your calendars. And my name is Jakub. I'm based in Poland. So now, for me, it qualifies as late evening, I would say. It's 9 p.m. in here right now. And today we are going back to the basics. So back to school, one would say. By the way, since the beginning of that week, schools are unfortunately closed in Poland, or the teaching is done, in the hybrid mode. It's of course due to COVID-19, so by the way, I hope you are all safe and healthy. That's the least we can do, so we can meet online instead of meeting offsite. Hopefully soon our shows will be back in a different form. So I said that today we are going back to the basics, and by basics I mean good old-fashioned modeling, some testing, etc., etc., etc. We are going to talk about object orientation. So today's episode is mainly for juniors, for people who are less experienced when it comes to programming. But if there is any senior watching us, I hope you will find something interesting in that too. All right, so I said that we are going to talk about object orientation. So enough of the introduction. Let's start with an example. All right. So let's say we have this kind of a situation. So, by the way, the basic idea behind object-oriented programming is sending messages between objects. So the basic concept, the core concept, it's not, by the way, object orientation, but message orientation. Is the message which is the core of OOP, by the way, not the object or class itself. So there are languages, purely object-oriented languages, where the only way of communicating between two different objects is to send a message and wait for the response. The receiving object can validate and handle the message or the messages according to some internal rules or invariants which are private, which are internal. Those are represented by those red rectangles on that picture, and we have found three messages: withdraw money, repay money, and give me my current available limit. In Java, sending a message like withdraw, repay, give me my available limit, my current balance, in Java those messages are represented as public interface, or the public methods of our object. And we are not talking about getters and setters. They break encapsulation, right? They reveal details about our classes, about our objects. They reveal data which should be private, and if the data is revealed, it might be used to check some rules outside, right? Which means, in turns, our software becomes hard to change. Which means, in turns, that people can skip those rules and we can get our system into an inconsistent state. So a very important question is that how we group those messages into a cohesive objects. So into a collection, how we group collection of behaviors to be handled by one specific class. For instance, I might get into a conclusion that one object should handle withdraw, repay, and available limit messages. And when I know what messages should be handled by this object, it's easier for me to name it somehow. You know, that's the very tricky part when it comes to software development. I mean, how to name things, how to name stuff. So if you find beforehand what the class can do for us, what the instance of the class or the object can do for us, it's easier to call it. In this case, let's say we grouped withdraw, repay, and available limit into one class, and it's called a credit card. And for the sake of the time we have today, we are going to skip the reasoning behind why those specific three messages were grouped into one object. If you want to know more about this, I strongly encourage to read about cohesion, about high cohesion, and about good old-fashioned practices behind OOP. But one thing I want to highlight, and I think it's a common mistake, is that when we have this kind of a conclusion, one might get into a subsequent conclusion, which would be, hey, I have a credit card class, so that's a great place to put a different message into, like change picture. You know, those credit cards, we have a plastic representation of a credit card, and we can change drawing when a client wants to do so. So I have credit card, it can change its picture, so why not putting this message into the same object? And same with, hey, show me some withdrawal history because I want to have it because of some audit purposes, for instance, right? And so on, and so on, and so on, and so forth. After some time, all of a sudden, our class handles like 20 different messages, and it's not credit card anymore. Credit card is here, no more. I would say that it just becomes a so-called God class. Even though we have behaviors, even though you might want to say there is encapsulation, there are no getters and setters, we communicate with our object only by sending messages, this object handles almost all of the messages that we came up with. So the entire set of messages has one specific handler. So this is a commonly seen mistake. And why we run into this trap, why we fall into this trap. So the reason behind this is that we fail to recognize that even though we have credit card which might handle different messages, those messages can be grouped into different modules. So the way of not falling into this trap is to accept differences across a single business. The idea is to embrace the fact that changing the drawing on a plastic card, for instance, has nothing to do with repayment. Well, if there was a rule saying like the picture on the credit card cannot be yellow, for instance, if you want to repay more than $200, then yes, probably this behavior change picture would fall into the first to the left class, so in the billing module. But don't get me wrong, but I would say that that would be a very stupid rule, right? There is no rule that spans across picture and repayment process. So if we don't have any, why we introduce coupling in our software if there is no coupling in this problem space or the business space? There is no rule behind those two different concepts. Same applies to history of our withdrawals. It might be like a separate module, a completely different module. Let's call it, for the sake of this presentation, audit module. Why not? And thanks to this, we have a nice and clear separation and boundaries between different objects, and those different objects have different behaviors. That means they handle different messages. So that's, for starters, enough with the pictures, enough with the drawings, enough with theory. Sleeves up, and let's get onto code. All right. So as you can see, here is our credit card class, which handles three different behaviors, three different messages. We can withdraw some money, we can repay some money, and we can ask, hey, what's the current available limit of my credit card? And when it comes to the first two, we specify the result in success or failure. And of course, it's not implemented. But if we have the behavior, if we have the messages, so we have the public contract, and we know some rules behind this object, like when can we withdraw, what's the rule or the rules if it's more than one, behind withdrawals, behind repayments, and so on and so forth. And if we have a class specified, like credit card, there is nothing which would prevent us from writing some unit tests. We have some business scenarios, right? Let's try to do that before writing the implementation. I will create test. Let's call it credit card test. That's good for starters. I will create the first test. And the first scenario would be pretty straightforward. Should be able to withdraw when, let's say, when there is enough money, of course. That's a simple rule, right? So one good way, I would say, of writing a unit test is to start from what we want to assert at the very end of that test. It keeps the test minimalistic. So I would start with then section, which is the last section of our nicely structured unit test, and I'm expecting I should be able to withdraw, so I'm expecting success, right, as a result. I'm also expecting that I will change the balance. Let's say that new balance will be 90 bucks. Why not 90 bucks? If we ask our card of, hey, what's your current available limit? That means we need to withdraw. When card dot withdraw, let's say we are going to use 10 bucks. Why not? Good. Which means now we have to create this card. So I will do that in the given section, credit card, let's call it card, so that the code compiles finally, maybe. A new card with initial balance equals to, let's say, 90 plus 10. We are expecting 100. Of course, this currency should be described in one place so that we don't copy paste it every now and then, but let's leave it like this and see for a while if the test compiles. So I'll just create new credit card. I will pass balance. I'm expecting balance here, not US dollars as the name of the parameter, which means we need this constructor. Okay, so far so good. We expect the result in here. All right. I think we are good to go and start. And of course, I'm expecting that this test is going to fail because there is no implementation. But at least now we know what we are getting towards, right? Expected 90 bucks, actual is null because we are returning null. So, okay. Let's start writing the implementation. If not enough money to withdraw, so notice what I'm doing. I'm just writing sentences in plain English, and later I'm going to think about how to implement that. But if there is not enough money to withdraw, I specify that this is a failure. I'm sorry, you cannot withdraw more money. All right? Otherwise, there is success. Okay, so now we have to ask this question. We know what the question is about, and here we are going to specify how, right? So I guess we need to compare the withdrawal amount to the current balance. So I guess we need some data in our class, like balance, create field, balance. and we specify balance at the very beginning when we create our class. That's initial balance or current balance. So now we get to compare. We don't have enough money to withdraw when the withdrawal amount is greater than our current balance. I think that makes sense. And now we can return available limit, which is just equals to current balance. So far so good, I guess so. Withdrawal amount greater than balance, that means that's a failure, otherwise that's a success. If that's a success, probably we should be changing some state because we have used some of our money. So let's change it. Balance is now balance subtracting the withdrawal amount. And thanks to this, hopefully the test will be green, or at least there will be different error. It's green. Great. So let's start with a second test. Let's say there is a different rule, like saying, or maybe let's now do the opposite. Should not be able to withdraw when there is not enough money, right? We have 100, we want 101, which means it cannot be done, and we are expecting still 100 as the current balance because we haven't used anything. Let's run this test and hopefully it's green too. It is. Great. And now let's say that we have a different rule, saying like, whoops. I'm trying to think about something new. Alright, let's say we have a limit of withdrawals per billing cycle. So it doesn't have anything to do with the amount of money, but the number of withdrawals. So should not be able to withdraw when more than 45 withdrawals in cycle. I don't know if that's something that banks or any other financial institution introduces in their software, but let's just imagine there is such a rule. So if we have a new card with some initial balance, let's say that 45 times we withdraw from credit card, and each time we use, let's say, $1. I can do that with for statement. I will just do with int stream. That's the other way of doing that. For each card, withdraw $1. All right, that's our given, and 45 times withdraw from card when someone wants more and still they have money, but the other rule is going to kick in. Even though you still have money, the current available limit should be equals to 55 if my brain serves me well right now, but next withdrawal shouldn't be able to be done, and we are expecting failure. So of course this test will fail because we haven't implemented this rule yet. It's failing. Good. In this line. So now let's introduce the second rule. If too many withdrawals in cycle. How we are going to implement that? We can either keep list of all of the withdrawals that have been done in the past, but easier way of implementing that is just to keep an integer or maybe class, a counter which cannot be negative. For starters, I can just use integer. Why not? It's still a local decision that can be easily changed after we are done with all of the testing, because it's going to be private. I will call it withdrawals in current cycle. At the very beginning is 0. Now we can compare. If we have already 45 or more, then I'm sorry, but more cannot be done. There is no more withdrawals to you, dear customer, and we are returning failure, which means if we succeeded, we have to increment the withdrawals counter like this. I have no idea if that's going to work, but hey, that's why we have tests, right? So let's try and see. By the way, I have no backup plan for this live coding demo, so hopefully demo gods are with us today. So far so good, the test is green. Let's do something different, like repayment as the last test. Repayment should be able to repay and withdraw. Let's make it more complex. So I have a credit card, I'm going to withdraw something, right? And then we are going to repay. Let's withdraw more, like 10. And then let's repay 10, which means we are now able to withdraw 100, the initial limit, the entire limit. So this should be successful, right? And the balance should be 0. Hopefully this test will be not green right now, yes, because we haven't implemented the repayment. So repayment is always successful when someone gives you money, just accept it, right? But we should change the balance, right? I have an idea that this is a simplification of how credit card works, but you know, it's just for the sake of the presentation. Balance at repayment amount. Now we increase the balance, and now let's run all of the tests, and hopefully all of those will be green. That's the case. Yay. So one thing I want to emphasize in here is that when you write tests like this, let's say that those messages like withdraw, repay, and all of the parameters like money in this case with currency, that becomes the public contract of our class. So now our test is coupled to the public contract. If you remove withdraw message, of course the test doesn't compile. That's why they are coupled right now. If you change the API from money to something different, the test doesn't compile. You have to change that everywhere. Like all of the clients of credit card class will be changed each time you change the API, the public contract, the messages that credit card class handles. That's pretty obvious, right? So we should tend to create classes which have stable contract and implementation details which are not leaking to the outside. What I mean by that is that maybe you don't want to use money inside of your credit card class for various different reasons. I don't know. You don't want this external dependency that's some external library. You want to implement that yourself. You don't need currency, etc., etc. But you want to be able to maybe in the future handle currency. So you are free to implement the inside of your class whatever you like. And all of the classes that use credit card, they shouldn't care. Like the class credit card test, which is a different class, which uses credit card, shouldn't care if I change it to big decimal right now. Of course, the decision is local, and all of the mistakes I'm having right now, or all of the compilation errors, are local. You know what? Maybe we can try to change it to big decimal and to private string currency. I know it's not good when it comes to modeling. I have an idea about this, but let's try and change it to those two different implementation details which are serving as money. All right, so it should be balance get number stripped if my memory serves me well. Yes, good. And this currency should be balance give me currency. Let's use just code, and that's it. So what we have to do here is to use big decimal instead of money. Here it's going to be a little bit more complex. Withdrawal amount compared to balance. Withdrawal amount get number stripped compared to balance greater than 0. Now we are talking about big decimals. And here balance at repayment amount get number stripped And here we have to now translate those two into money. So into a stable contract which cannot be changed, but internal details, they can be changed. Return money of balance, and so all of the changes are done, as you can see, locally in this class. So if I want to change that, if let's say I have a bad day and my implementation skills today are not good, my modeling skills are not good, as long as the details are not leaking, I'm able to change everything inside. As you can see in my test, it should be still compiling. Moreover, it should be still green, of course, if I haven't done any mistake inside of the credit card class, but it is green. So as you can see, I can do whatever I want. I can just keep list of withdrawals in here. I can just play around with that. That's my local decision. That shouldn't be leaking outside. All right? So that's the first part, when we have implemented business rules. According to some invariants we found in business specification, we grouped that into some objects. We call those objects respectively differently in different modules. Maybe we have 3 credit card classes, but all of those are placed in different modules, etc., etc. But now, a common thing that I'm seeing is that, hey, if I have credit card, probably this object will become an entity that we are going to store and retrieve back and forth from the database, right? Which means if I have an entity, I have a service which is named after this entity, in this case, credit card service. So I have entity with getters and setters commonly, like credit card, but not the one we implemented just now, but just with getters and setters. We have credit card service, which means each entity in our code base gets its own service. I'm pretty sure you have seen that. The credit card service uses getters and setters to check rules, the red rectangles, inside of some methods like withdraw, repay, and so on and so forth. On top of that, credit card service not only checks rules, checks invariants, but it also implements some kind of a business process, some sort of a business process. Maybe the withdrawal process ends up with, an email being sent to a client. So I have to have a dependency from my credit card service class to an email sender. Maybe repayment process, which is implemented in the same class, creates some audit trail in my database or any different data source. So I need a different dependency that is used solely for the purpose of repayment process. And so on and so forth. Which means at the end of the story, I have to depend on so many objects from my credit card service that it's really hard to test the behavior, the rule checking invariants, and so on and so forth. It becomes hard to understand, hard to test, hard to maintain, hard to fix, and hard to extend, right? Why? Because we are mixing rules like can I withdraw, can I repay, with processes like each repayment ends up with an email and so on and so forth. So we have a huge class with a lot of if statements and a lot of external dependencies, which is basically untestable. So maybe if we do something different and if we for a while stop thinking in terms of, hey, for each entity I have to have a service, maybe a better way of separating those concerns would be I have a service per use case to make it more cohesive, which means things that change together, like business process stays in one place, and things that change for different reasons, like rule checking and invariants. Probably the red rectangles are more stable than the green ones. It's in a different place because those two things, they have different rate of change, probably. So on top of our credit card class, we have a use case, withdraw service. The logic behind withdrawal is delegated to credit card. The process is implemented in the withdraw service. The dependencies in the withdraw service are, limited to the needs of withdrawal process, of course. So, for instance, there is no dependency needed for repayment, which tremendously simplifies understanding the classes, testing the classes, and reduces coupling. Probably some of you have heard about good old-fashioned, well-known acronym of 9 great rules in software development. It's called GRASP, General Responsibility Assignment Software Patterns. One of those rules is called a controller, not to be mistaken with an HTTP controller. Controller is, for instance, this withdraw service. It's a controller because it's a pattern that assigns the responsibility for a non-user interface class that represents the overall use case, the overall scenario. The class deals with general scenarios like business use cases. So let's try to implement that in code. Instead of having credit card service, I will have withdraw service. Why not? Service. Right? Which means it gets probably one public method. Let's call it withdraw and return result. I'm guessing it needs 2 different parameters, like the amount of withdrawal and from which card ID. All right, let's fix this and that too. So in this case, processing would be very simple, like a load card, call withdraw, save back, probably to the database, but I don't know that yet. If I don't know that yet, if it's database, if I don't know the type of the database, I know that I need 2 different behaviors, load by ID and save back somewhere, from somewhere to somewhere, which means I can use repo or database implemented as maybe represented by an interface with 2 different behaviors, get one, save. By ID, save this credit card back to somewhere. Maybe it's a file system, maybe it's a remote service, maybe it's a database, maybe it's document-based database, maybe it's relational database, and so on and so forth. Maybe it's in-memory repo at the end of the story, right? So I need one external dependency, like this, inject via constructor, and now I'm pretty sure I'm ready to write this code. Hey, credit card, where are you? I want to find you by ID. Of course, yes, an optional would have been better in here. I would like to check whether a card exists. Let's skip this for a while. It's really easy. Credit card, withdraw amount, and save it back to the database, right? That's the end of the story. Save credit card. Oh, you know what? I am returning the result, so let's call it withdrawal result, and return it at the end of this method. All right. 3 different steps, 3 different lines of code. Very, I would say, easy code, almost procedural, right? Load, call, save. Of course, we might have a more complex scenario, like send email, like do something else. Maybe if the withdrawal was not successful, do something different. So there is an entire process. And of course, I will have different class for repayment service, which would have different dependencies. Maybe repayment service doesn't call an email sender, which means it only gets dependencies it needs, which simplifies understanding, testing, and reduces coupling. I can also test that code. Of course, the logic behind withdrawal is already tested. But if the process is that easy like this, I can even test my business rules from the level of this service. Like this. Credit card test. Let's create a withdrawal service. New, it needs one dependency, but I have no idea what's the database behind it, so I cannot create a new class which connects to database like JPA, maybe document-based database, or to remote service, or to file system. I don't know that yet, or maybe I just want to show some demo to business stakeholders while I'm waiting on database being set up somewhere else, because in our organization, from whatever reason, it's a long-running process. Anyway, I want to test that. So maybe I can use in-memory repo or in-memory database. It's not H2 because I don't know if it's going to be relational. So I just want something which gives me from memory database credit cards and can save back to memory. Create field, and I'll just call it in-memory database, new in-memory database, which means we have to create this class, which will be implementing credit card repo. So you know what? I'm going to choose almost production ready hash map from ID to credit card. Let's call it cards. That's our database. And that's pretty straightforward what we do here. Cards get by ID. And here what? Return credit card. But before that, credit cards put credit card get ID. Not get, but put, right? So maybe if my database is set up already, I'll implement that in a different way. So I'll just use different implementation depending on my needs. Here in the test, I'm using in-memory because it's easier. I don't care about database communication. I want to deal with that. And I want to show something to the business. I want to test that. Test. And as I said, if the process is that easy, maybe we can delete those tests and just copy paste them to here. I will do that with one test. Like this. Should a new card with initial balance equals to some specified amount. So here I want to create in our software new credit card which is stored in the database. So I'm going to cheat. I shouldn't be doing that. Probably there is already a use case in the software which creates credit cards from scratch. So probably I would have to use something like create card service, a different service, which would create a new card. But I will skip this for a while, and I'm going to touch internal details of my architecture just for the sake of the presentation. Don't do that on production. I should have been using here something like create card service. Save a new credit card with some balance, right? That should be a variable, and let's return maybe just an ID. Cool. Which means this is not compiling. And now we are using withdraw service to withdraw, and we have to pass the ID as the second parameter, right? This can be deleted. I would have a different service checking the available limit. And I guess this test will be very easy to become green, hopefully. Yes, this is what's happening every now and then with my ID. Sorry for that. I should have mentioned that at the very beginning. I couldn't find the root reason behind that, but the restart helps. So hopefully we are going to be back online soon. I mean, with the code soon. In the meantime, you can see what's on my desktop. Loading. So I guess that was the first and the last time when the ID crashes. That's something with the combination of new version of Java and new version of IntelliJ. I have just upgraded. Alright. So now it has to index. Alright, let's run this test and see if that's green. It is. Cool. Great. So let's take a look for a while at slides. We have been talking about controller. We have been talking about withdraw service, which has just the business process separated from the rules. Two different rates of change, rules versus process. Some people call it an application service. It's from domain-driven design terms. And the object would be an aggregate, so the one that backs up the invariants. So the credit card would be the aggregate, and withdraw service would be an application service. Of course, the application service will be the one contacting external systems like via SOAP, REST, RPC, maybe some queuing system. It also talks back and forth to the database. All that stuff that you don't want inside of your nicely crafted aggregate credit card object, so that the object can be self-contained and can deal only with the rules and can be easily tested without external dependencies. Of course, you might want to have different application services touching the same class, like repayment service, or I don't know, cancel card service, create card service, etc., etc. That way of organizing code reduces coupling, as we mentioned. The rules are not coupled to process and the external services. What changes together stays together. Rules have different rates of change, etc., etc. That way our design becomes more stable. Of course, I can create more processes using the same rules, which are already implemented in credit card class. Commonly, if you use Spring, application services like withdraw service or repay service would be Spring services, Spring Beans. But that's specific to the technology. If you are using something different than Spring, or even if you don't use Java, the same knowledge applies. You are just using different components, but the same patterns, like controller from GRASP or application service from DDD or aggregate from DDD. All right? Those application services, they are injected into higher level classes like UI, like stuff that handles HTTP requests, queuing requests, etc., etc. Or maybe all of the services are grouped into one facade that's called billing facade in our billing model, and the facade is the only one which is injected into higher levels. So you might want to have different models implemented in the same manner. Maybe some of those require different architecture, like good old-fashioned entity service, because it's basically CRUD. So you don't want to use this kind of architecture in CRUD. So the idea behind this is that if I do that, I can take one bit in isolation, like one module. I can replace the implementation if I want. I have different modules with different business capabilities. Inside of those modules, still I have multiply smaller chunks like credit card classes and so on and so forth. I can test them in isolation. I can move them around because they don't have external dependencies. So that's a very flexible design. Few words about testing, because we have tests in here. So at the level of application service and in here. So as we can see in here, withdraw service, it's a very simple class. It's very hard to do a mistake in here. It's load, call, save. Probably it will deal with transactions, database transaction, maybe security, maybe some logging, etc., etc. But still, it's pretty easy to implement. It's hard to do a mistake, and even if you do a mistake, one kind of a mistake you can do is that you cannot inject some implementation because there is none in your context or something like that. So even if there is a mistake, they will be easily spotted via integration testing and so on and so forth. That leaves us to a conclusion which looks like this. Maybe we don't need tests on this level. Take a look at this. If we think about our tests according to three different questions, is the implementation effort of a test hard? When it comes to domains or credit card, it's very easy. You need tests without dependencies. When the process is complex, you need to use some different dependencies for the testing purposes, like I have used in-memory repo, but if you have more, you have to use more. So implementation effort is not that easy, it's higher. How about possibility of mistake? When it comes to business rules in domain, in the aggregate, in the credit card class, there is a lot of if statements. A lot of nitty-gritty details that might go wrong, so the possibility is high. When it comes to application service, which is step by step, load, do something, save, send email, blah blah blah, it's low. And the severity of mistake is low, because anyways, the mistake is going to be seen probably before going to production, whereas when it comes to domain, it's going to be probably found via some client being mad at us because they couldn't withdraw or repay, even though they should have been able to do so. So if we take a look at this, implementation effort is low, mistake probability and severity of that mistake is high, test as long as you can, as much as you can at the domain level. If the application service cannot be tested easily, then I would say, just between us, skip that. And third rule, if the application service is as simple as here, probably we can test like this, which means I am able to test both process and business rules from this level, which means this will be gone. So depending on the situation we face, there is a different technique, different strategy we might want to choose. All right. So another commonly seen challenge that we have is that, okay, we have a stable software and now there is a new behavior to implement. We have to be able to close the current billing cycle. So there is a new behavior and the question is where I'm going to put that? What's the object that should be handling new messages like close billing cycle? Whose responsibility is that? So with this explanation, like I should be able to close billing cycle, the current one, I would say it's hard to judge. This is a very poor business requirement. So if we face situation like this, one at least heuristic that helps me is to ask myself, okay, and so what? I can close the billing cycle for the sake of closing billing cycle? Or is there something really important behind this? What's the business consequence that can be observed after closing the billing cycle? If I ask myself this question, maybe I run into a conclusion that we don't close it for the sake of closing, but the consequence is that the client can withdraw again, right? If they have money, of course. And now we might get into a conclusion that withdraw touches, as we have seen, one data in our class called withdrawals in cycle counter, the integer, and the new implementation close cycle would touch the same data because we have to reset that. If you apply this way of thinking, now we probably can guess that the object that should handle this close cycle message is credit card, right? So let's try to implement that. Of course, starting with a test which is representing the real consequence, like not I am able to close the billing cycle for the sake of closing, but the client is able to withdraw in the subsequent billing cycle. Should be able to withdraw in next cycle when number of withdrawals in current one exceeded, right? So I have a card. You know what? This one would be great to copy paste, the one with 45 withdrawals. Credit card, a new one with 100, 45 withdrawals. I want one more. That shouldn't be possible unless, in the meantime, someone closes the billing cycle, right? And now I can withdraw more. I should have 54 as the current balance, and that should be a success. So we have to implement this. Of course, just for the sake of doing proper test-driven development, I'm going to run this code and see it probably crashes. Yes. Failure, success. So close billing cycle should do what? I guess it should just reset withdrawals in current cycle. All right. Let's try to run it. By the way, that should be end. And when I'm going to withdraw in the next cycle, so that's a withdrawal in subsequent cycle, now it's success. So we're done. That was as easy as this. The important is that we found a place to place our new message. Just asking ourselves questions about the consequences, asking ourselves about what data I'm going to touch. So now I can see that there is an invariant, there is a rule that spans two different behaviors, and the rule says 45 withdrawals per billing cycle. That's max. Not anymore. All right? So let's see that we finally have found or set up the database, and we are going to use JPA. So let's say I'm using Spring Data JPA to talk with my database. So I will create a new interface. I guess you are familiar with Spring Data JPA. It doesn't require to implement. It requires only to create a new interface, and Spring Data JPA is going to do all of the things on my behalf, which means if I want to load one or load one by some specific property, it's going to be done automatically. So I'm going to call it JPA repo, credit card repo, and it's going to extend the current repo. So that's the extension of current repo, and also extension of some bits from Spring Data JPA. That way I can have the automatic querying and so on and so forth. It requires me to add the entity itself and the ID. So in this case it's UID, right? Which means now it will be handled by some ORM. It will be an entity with an ID, and if it's an entity with an ID, it requires me to have a public empty constructor. My heart breaks when I have to write it, but hey, that's a sacrifice, right? Entity ID, we have a new repo. So now I can easily replace that implementation if I make a Spring Boot test, which becomes an integration test with a context with Spring Data JPA in place too, and I delete that, and this Spring will try to auto-wire dependencies into withdraw service. There is one credit card repo. Hopefully it will inject JPA credit card repo, which is JPA repo, which means now we are able to talk to H2 database by default. But our implementation, as you have seen, it hasn't changed a bit. Or maybe I have to add this, right? And I have to add transaction, some meta annotation, so that Spring knows it's a service. It becomes part of my context, right? Enough of talking. So I have a withdraw service, I have Spring Boot test, now it will be integration test. Oops. Yes, so I need something different in here, like I need auto-wired credit card repo to create that from scratch. Again, I should have been using something like create card service. Run. So I have no backup plan, that's the first time I'm doing this, so hopefully the test will be green. I haven't seen any mistake, the test is green. As you can see, when it comes to the implementation of the test, we haven't changed anything, we just changed something in the setup, right? We haven't changed anything in here, so at some point you might want to decide to move from one kind of implementation with another kind of implementation. The same applies not only to the database, but for instance, let's say you have a something like allow list, right? And you don't know how it's going to be implemented. Like if you are going to, let's say, integrate with some third-party software, or maybe you are doing that in your database, we have no idea. But the process knows that it should take something from the allow list. Like I can withdraw if and only if I'm on the allow list. So I can have interface allow list, which would have one method, am I on the allow list or not? And for the sake of testing, I'm going to implement that with a collection or with a set. And when it comes to production, I will just change the implementation. The process will be stable, the class will be stable. All right. That's a good old-fashioned technique, nothing fancy, programming to the interface, right? One last thing I would like to show is, let's say that we have some fee when it comes to withdrawal, and the fee is taken into account when it comes to checking money. So it means that when I want to withdraw 100 and the fee is $2, and I have just 100, it cannot be done because I should have 102 to do that. So I can withdraw 98 tops. So how to implement that? One way of implementing that is to, of course, add fee in here like this. Money fee equals money of $2. Of course, it's not, it shouldn't be hard-coded. We could put it in here, but you know, this is still hard-coded in the terms of like, it's constant, but maybe we have some flexible design, like now it's withdrawal amount, like 3 or 4% of withdrawal, like this. And tomorrow it's constant. And the day after tomorrow it's again percentage based, and so on and so forth. So our software should become flexible, and all of you probably know that strategy pattern is good for that. So if I have a strategy, like withdrawal policy or withdrawal strategy, let's call it strategy, withdrawal fee strategy, and it has one public method, calculate fee based on withdrawal amount, let's say. And now we can have like constant fee implements withdrawal fee strategy, right? Of course we have to implement that. Let's inject something via constructor like fee, and now just return fee. And maybe tomorrow we have something like percentage base, right? Percentage based fee, which means I need to have integer here, percentage, sorry for the typos, int, all right. So how to calculate that? It's withdrawal amount multiply by percentage, divide by 100, right? I guess if we have tests for that, they would tell us the truth. Let's leave it like this. And if I have constant today, let's say, I can just use withdrawal fee strategy. Let's say it's $2. But again, it's still hard-coded inside of the method of our object. Every time it changes, we should change our class. I don't want to do that because probably the rate of changing this, it's less frequent than this. So it shouldn't be kept inside of our class. So maybe there will be someone passing the withdrawal from the higher level, like this. But now we have a bunch of clients which don't use this because so far our code has been working without any fees. So to keep them satisfied, maybe I will have a different method like this. Oops. And I'll just return delegation. I'll just use delegation. Withdraw withdrawal amount, withdraw, and either no op fee or maybe new constant fee 0. Let's see if that works when it comes to our test in credit card class. That works. So now let's change the actual checking. So the money fee equals withdrawal fee strategy, calculate based on withdrawal amount, which means now the total I want to withdraw equals to current withdrawal amount plus fee, right? So we are going to check that in here, and we are going to use that in the balance. All right, let's try this. It should be 0, so the test should be still green. They are cool. So still, there might be different requirements, like client A gets different withdrawal strategy, client B gets different one, and so on and so forth. So who is going to decide which strategy is going to be applied? So again, one way of doing that would be in here instead of passing the withdrawal fee strategy as a parameter, but that would create a huge coupling to an entirely different set of business reasons, business requirements. Like when we apply the strategy, not what we are calculating. So the reason to apply some withdrawal fee strategy might be different on client basis. Like this client has 0 because we want to apologize. Today, all of the clients have 0 because it's Black Friday. Or today, all of the clients have percentage base, but the percentage is lower than yesterday because it's Thursday and we want to encourage people to, take loans before weekends. Don't ask me where I have those kind of ideas. And so on and so forth. So there is one question like when we apply the strategy, and this entire different question like how the strategy is taken into account. So this is like what we do with the fee, and there should be somewhere in our system, probably somewhere in here, like what's the current strategy? Fee factory, give current for client ID if we know it, and so on and so forth, withdrawal amount, card ID. We can pass whatever we want. The important is that this class fee strategy factory is going to implement all of this not nice logic like, hey, if it's Friday, then return new constant fee. Hey, maybe it's a client birthday. Just for him or her, give 0. Or maybe we want to apologize to this one. So again, maybe we are going to lower the percentage. So this logic would be here, which means this is still stable. And so is our credit card class. So this is when we apply. Of course, we might want to return like a couple of strategies. Maybe there are a couple available. If we don't want to reveal that implementation detail, we can have a composite fee, which would have like a lot of strategies inside, right? And so on and so forth. So in that way, our software becomes, again, more flexible, and the changes which are representing when we apply one strategy are done in the fee strategy or in the decision maker in the upper right corner of this diagram. If it's Friday, if the client is VIP, is that a global discount applied to everyone? I don't care. I just want, as credit card, current fee policy or current fee strategy or current fee, whatever we call it. So the service now works like this, the process. Hey, what are the policies? These are the policies. Load the credit card, call withdraw, save it back, and that's it. The rules stay inside credit card. The process is the same. And the reason to change the fee strategy is in a different component. So we have 3 different components with 3 different reasons to change. All right, I think that's it. Hopefully you have found it useful. If yes or if not, if so or if not, just please write me a DM on Twitter, like saying, hey, this was all bullshit, or hey, I found it interesting. I'm happy to talk about it. If you have any questions regarding this or any other show we have, just feel free to drop us a line. And have a great afternoon, evening, or morning, depending on when you are. Bye bye. This was Back to the Basics. Think about modeling and testing.